Do you ever listen to your favourite song with just one ear in and notice just how much is missing? Maybe you're walking down the street or talking to a friend. You want to hear the world around you, but in doing so you compromise that fully immersive musical experience. What does this choice to mix the music differently in one ear to the other bring to the listening experience? My name's Ruairi from the Glasgow Science Centre, and today, with the help of some volunteers, we're going to explore exactly this question. But first, a short history lesson. Back in the early days of commercial music, songs were produced and released in what were called mono audio recordings, where all the instruments and all parts of the song were recorded to one audio channel. In other words, when you stick on your headphones and listen to an old mono recording, what you hear in your left ear is exactly what you hear in your right. But as technology advanced through the 1950s and 60s, musicians became increasingly interested in releasing their music in stereo. As opposed to mono recordings, stereo uses two audio channels. This meant recordings could now be played using two speakers, and it didn't have to be exactly the same sound that played from each one. So, you could create a sense of space. Different sounds could now be perceived as coming from different directions. If you wanted, it could even seem to the listener that they were at the centre of the band, with each instrument coming from different corners of the room. Using two channels allowed music producers to build a soundscape in our brains, a space in which the music lives. Now, the process by which our brains interpret sound is complex, but put very simply, we are also using two channels, our ears, to create this soundscape. The same sound will reach each ear at a different time interval and at a different volume, and this is what allows us to determine where the sound is coming from. If a noise reaches our left ear first and is louder in that ear than in our right ear, our brains understand that whatever is making that noise is likely to be on our left-hand side. This might seem strange at first, but when we think about it, most of us are familiar with this kind of behaviour in other animals. Take the expression blind as a bat. Bats don't use sight to navigate, they use sound, using their ears to map their environment. And to a lesser extent, humans do this too. This is where my volunteers come in. For this experiment, I've enlisted the help of my two flatmates, Natalie and Caitlin. They're going to be putting human ears to the test in a simple game of Marco Polo to see just how well they can infer direction from the sounds they receive. You know what to do?
Marco! Polo! Marco! Polo! Marco! Yay! You did it!
They did pretty well at that. Just from the differences in sound picked up by each ear, a human can in fact locate the source of a noise. But what would happen if those signals are altered? What, in fact, if they can't be trusted? Let me introduce you to the confusophone. Now for the part they don't know. We're going to be playing one more game of Marco Polo, but this time there's going to be one crucial difference. They're going to be wearing my confusophones. With these funnels, we're swapping the sounds that are detected by each ear. So, sounds that are usually reaching the left ear will be piped to the right ear and vice versa, which should make pinning down any sense of direction a bit more tricky. Let's give it a go. Alright, Natalie? Good luck.
Marco!
So as you can see, our brains are smart. They can infer a lot from subtle differences in timing and volume, which can be used in music to create a truly immersive listening experience. But it only takes a small difference in how those signals are received to change that experience.
I found you!
Quite dramatically.